Hello everyone, it's Wilson here. Today, let's talk about finding an equation of the plane that passes through 3 points. Okay, so the 3 points are given here. The P, and then the Q, and then the R. Okay, so we know that if those 3 points are not collinear, then it will determine a unique plane that contains all 3 points. And so how do we find those 3 points? What we need to do is to find the point that's on the plane. And in that case, we actually have more than enough, right? We have 3 points. And the other thing that we need is to find the normal vector that's perpendicular to the plane. And to do that, we actually need to use a cross product of 2 vectors. And those 2 vectors must lie in the plane so that when we cross those 2 vectors, we can get a new vector that's perpendicular to those 2 vectors. And in that case, when that normal vector that it's perpendicular to those 2 vectors, then it will be perpendicular to the plane. And so what we're going to do right now is to form 2 vectors that will lie in the plane. Now, how do we do that? It's really because when we have those 3 points that lie in the plane, if we use those 3 points to form 2 vectors, then those 2 vectors will lie in the plane. So now how do we form 2 vectors? Let's do that by doing by subtracting the x, y, and z values respectively. Okay, so let's do that. So one vector that lies in the plane can be constructed by let's call this one v1. Okay, so let's call this v1. So that's really just what it can be constructed by taking the point Q. So actually, let me just write, okay, so let's just call that vector PQ. Okay, so let's just call that PQ. And then how do you construct this vector PQ? You are going to use the point Q, and then you use all those x, y, z values, and then you're going to subtract the x, y, z, the corresponding x, y, z values for the point P. Okay, so what we're going to do is that for the x values, for the x component, for the vector, you take the 8, right? So you take the 8, then minus the what? Minus the 3 right here. So 8 minus 3. Okay, next one is to take the y value of the point Q, which is a 2, and then we are going to subtract the y value of the point P. So when you subtract, then you actually need to pay attention to the sign. So we are subtracting -1, right? So it shouldn't be subtract 1. It should be subtracting -1. And so the third component would be taking the z value of the q, and then you take the 4 minus the z value of the q, which is the 2. So we have that. And then now we do the calculation, and we have the vector, which is 5, and then 3, right? 2 minus -1, so we get 3, and then 4 minus 2, which is 2. Okay, so that's one vector that lies in the plane. And now we need to construct the second one. Okay, so we need to construct the second one. We are still using P as the initial point for the vector, but this time we are going to use a different terminal point. In this case, we are going to use a Q. Okay, so we are going to go from P to no, we're going to use R, right? We're going to go from P to R. So right now, we are just going to do the same thing here, same idea. So we take the x value of the R, subtract the x value of the P. So we're going to get -1 minus 3, okay? And then next, it would be -2 minus -1. -2 minus -1. And then lastly, we have the -3, which is the z value of the R, -3 minus the 2. Okay, so -3 minus the 2. So now we do the calculation. Then we are going to get what? -4. -2 minus -1 plus 1, right? So we get -1. And then -3 minus 2, we get -5. And so now we have v1 and v2, and those 2 vectors lie in the plane. So right now we need to determine that normal vector. Okay, so we need to determine the normal vector. So the normal vector is actually determined by what? Taking the cross product of v1 and v2. So that's what we need here. So v1 and v2, right? We got to cross them. And then when we cross them, that's really just getting the, we're just computing the 3 by 3 determinant. So the first row has the unit coordinate vectors, right? The ijk. Okay, and then the second row would be the first vector that we have, the v1. So we put the 5, 3, and 2 here. And then the third row would be the second vector, which is the v2. So -4, -1, and then -5. Okay, so now we need to compute this determinant. And so how do we do that? We are going to just do it like this. So we are going to expand the first row, right? So we are going to cross out the first row, cross out the first column, because we need to cross out the row and the column containing the I entry, right? So we're really just calculating this this 2 by 2 determinant right here. So our first component would actually just be 3, 2, -1, -5, okay, times I. Okay, now the second one we have minus, okay, then we are going to cross out the row containing the j and then cross out the column containing the j. Then we are going to form a 2 by 2 determinant also. It would actually be a good idea to use the line 2 here to just make my writing better. Okay, so now that looks a lot better, right? So now let's construct the 2 by 2 determinant for the second component for the normal vector. So crossing out this row here and then this column here, we get 5, 2, -4, -5, right? So we have 5, 2, then -4, -5. Yeah, so basically what we're doing is really just that we cross them out like this. And how do we get this this 2 by 2 determinant? It's just the entries that are left, right? 5, 2, and then -4, -5. Okay, so and then now the third one is to be adding, right? And then what do we get here? We are going to be crossing out. Okay, so we are going to be crossing out the row that's containing the k, and then also the column that's containing the k. And so now what do we have left here? What do we have left there? It's going to be what, 5, 3, -4, -1, right? So we do that. Just copy it there. Okay. So now the line 2 here, just to draw the 2 bars, right? And then times the third component, the k. Okay, and then now we can erase those. Okay, so now we just need to compute all those 2 by 2 determinants. And so if you remember how to compute them, then it would be easy. It's really just the main diagonal, right? Multiply them together, multiply all the entries in the main diagonal, and then subtract the product of the other diagonal. So it's going to be what? 3 times -5, right? So let's show the work here, 3 times -5. And then minus 2 times -1, right? The product of the other diagonal entries. And then all that, it's going to be multiplied by I, right? And then continue. So we have a minus here. And then what do we do here? So 5 times -5, right? So 5 times -5. And then minus 2 times -4. I'm actually showing a lot of work here. Sometimes when you get better, you don't need to show this much work because it will it will actually be quicker, right? If you just do it directly on here, you can come up with the answer really easily. Okay, so 5 times -1, right? So 5 times -1, and then oops, so we got to subtract, right? So subtract the other the product of the other diagonal entry. So we get the 3 times the -4, and then we have the k. So now doing the computing all those things. So let's do that. 3 times -5. That's what? That's going to be -15. -15 plus 2. So we get -13. Right? So -13i. Okay, so -15 plus 2, right? This one is -25. -25 plus 8. -25 plus 8. So we are going to be getting minus, right? It should be minus here. So sometimes it would be a good idea to just do a little bit of the calculation here, which will make it easier for us to see the signs, right? This is negative 25, and that's plus 8. So that's actually negative 17, but then because you have a minus sign in the front, so you're going to be getting, what do we get here? We are going to be getting positive 17j. Okay, so this one has a plus sign, so we can just do the mental calculation here, which is negative 5 plus 12. So negative 5 plus 12, so we get 7, right? Plus 7k. Okay, so we have all that, right? We have the normal vector now. So once we get the normal vector and we also have a point, then coming up with the equation would be really simple. So the equation of the plane, right, containing the PQR, okay, so the P, the Q, and R is given by what? It's given by now using the three components of the normal vector as the coefficient, right? So it will become negative 13, and then x. Now, we actually need to use one of the points. It would actually be a good idea to just use the p, right? It doesn't matter which one that you use, it will just be the same equation. So we have x and then what? Minus 3, okay? And then plus 17. And then y plus 1, right? Because it should be y subtracting whatever y value that you have here, but you have y minus negative 1, so we get y plus 1. And then plus 7, right? That's the coefficient of the z. And then that would be what? Z minus 2. And then that's equal to 0. Okay? It's up to you whether you want to simplify this equation so you can distribute the negative 13, 17, and then 7, and then get all the constants to the other side so that you're going to get ax plus by plus cz equals some number d. So in that case, but we are not going to do that here. We already have the equation. The rest, right? If you write it in the other form, it's really just algebra steps, right? So you distribute and then you combine like terms and all that. Okay, so that's it for this problem. To help me make math learning available to everyone, please share my videos to others and subscribe to my channel. It will give me support to make more videos. Let's work together to help students and children learn math more easily. Thank you for watching this video. I will see you next time.